Look at this image. This is a recently discovered early galaxy that existed approximately 13 billion years ago. Scientists found that this galaxy is far more massive and developed than expected for a galaxy in the infant universe. Surprisingly, this isn't the first time that the Webb telescope has uncovered such galaxies in the early universe. Since the Webb telescope began its journey, it has been challenging our standard cosmological theories. But the remarkable telescope didn't stop there. This time, it has unveiled a troubling revelation about the universe. Recently, a Nobel Prize-winning scientist disclosed that the James Webb Telescope has confirmed our understanding of the universe was fundamentally flawed. This isn't about large or luminous galaxies. This time, new and essential observations from the James Webb Telescope have shaken long-standing cosmological theories. Consider this. One of the central tenets of cosmology is that the distribution of matter in the universe is uniformly isotropic. This means that everything should appear identical in all directions if observed over large enough distances. This assumption is due to the expectation that forces act uniformly throughout the universe on a large scale, preventing any observable differences in the structure of matter initially formed by the Big Bang. Wherever you look, you should find similar matter density, temperature, and uniform expansion of the universe. For over a century, scientists have built cosmological models based on the assumption that our universe is consistent in all directions. The Big Bang model, which is the most widely accepted theory to explain the universe, is also founded on this idea. The cosmic microwave background radiation further supports that the universe appears consistent. However, a recent study published on February 6 in Astrophysical Journal Letters suggests that there may be something seriously flawed with this assumption. Recently, astronomers confirmed that the expansion rate of our universe isn't the same everywhere. This paper reveals that, depending on where we look, the universe expands at different rates. This is a significant issue. If the universe is expanding at different rates in various locations, it will present a major challenge for astronomers. This study also implies we may be entirely mistaken about the current estimated age and nature of our universe. David Gross, a Nobel Prize-winning astronomer, said, "We wouldn't call it a tension or problem, but rather a crisis." Let's explore this discovery further and understand how Webb's findings indicate a crisis in cosmology. In 1929, Edwin Hubble provided the first observational evidence of the expanding universe. Using the largest telescope of his time, he observed that the farther away a galaxy is, the faster it seems to move away. This suggested that the universe was expanding uniformly. Based on this discovery, scientists inferred that if the universe is expanding, then it must have begun expanding at some point in the past, implying that the universe has a finite age. By accurately calculating the expansion rate, known as the Hubble constant, the cosmic timeline can be rewound to estimate the age of the universe. However, before the Hubble Space Telescope was launched, there was significant uncertainty regarding the expansion rate of the universe, or Hubble constant. This value is essential for calculating the age of the universe, predicting its evolution, and understanding the forces driving its expansion. When the Hubble Space Telescope was launched, it suggested that the universe could be as young as 9.7 billion years or as old as 19.5 billion years. However, the younger estimate was problematic, as it implied that the universe was younger than the oldest known stars. Over the years, astronomers have employed many methods to measure the expansion rate accurately, yet surprisingly, each method has yielded different values. It's as though the universe is expanding differently depending on the observation technique used. Currently, there are two gold standard methods for determining the Hubble constant. The first involves analyzing subtle fluctuations in the cosmic microwave background, the universe's first light, emitted just 380,000 years after the Big Bang. Between 2009 and 2013, astronomers mapped this microwave haze using the European Space Agency's Planck satellite, estimating a Hubble constant of about 67 km per second per megaparsec. The second method involves using a Cepheid variable star or supernova as a distance marker. As Cepheids brighten, they pulsate more slowly, allowing astronomers to calculate their intrinsic brightness. By comparing this brightness with their observed brightness, astronomers can estimate how fast the universe is expanding. However, this is where the mystery deepens. According to Cepheid measurements, the universe's expansion rate is around 74 kilometers per second per megaparsec, a value significantly higher than Planck's measurements. Initially, some scientists suspected the disparity might be due to measurement errors. But recently, Adam Rees, a professor of physics and astronomy at Johns Hopkins University, stated, "We've now spanned the whole range of what Hubble observed, and we can rule out a measurement error as the cause of the Hubble tension with very high confidence." Additionally, new images from the James Webb Telescope confirm the accuracy of previous measurements, suggesting that the universe is expanding differently depending on the region observed. This inconsistency in expansion rates implies that the universe may not be uniform everywhere. If true, this would invalidate our standard cosmological model, as we cannot reliably estimate the universe's age and size with varying expansion rates. The most pressing question, then, is, why is the universe expanding differently in different regions? One possible explanation is that dark energy, the mysterious force believed to drive the universe's accelerated expansion, is itself not uniform. In other words, dark energy might be stronger in certain regions, leading to different expansion rates. Scientists suggest that if the universe is neither homogeneous nor isotropic, it could mean that the physical laws we understand are incomprehensible beyond our cosmological horizon. Gravity may behave differently, the speed of light could vary, and who knows, unicorns might even exist. This new discovery by the Webb telescope has ignited intense debate among astronomers. The non-uniform expansion of the universe challenges the cosmological principle, one of the fundamental principles of astronomy. Thank you for watching. Please subscribe the channel and press the bell icon for new updates.